Example 1, a particle moves according to the law of motion S equals t squared minus 4t plus 2, where t is measured in seconds and s is measured in feet. So s is measured in feet, t measured in seconds. So that's the position function. S represents where it's at, t represents how much time's passed. At t equals 0, 0 minus 0 plus 2 is 2, so it starts at 2 feet. At 1, 1 minus 4 is negative 3 plus 2 is negative 1, it moves back to negative 1 foot. So there might be a 0 spot here somewhere. It's just kind of moving left and right at this point, but that's kind of what we're thinking about, is where it's at in position at any given time. Part A says find velocity at time t. Velocity is the derivative of position. Okay, so if we're plotting s as the y-coordinate and t as the x-coordinate, if I do change in s over change in t, that's going to be a feet per second unit, which is velocity. So again, the derivative of position is velocity. So to do part A, velocity at time t, is simply the first derivative of the position function. The position function is a power structure. So if we use the power rule for differentiation, we're going to get 2t minus 4. Okay, that's typically the first question they're going to ask you in this section, find the velocity function, because every question they ask you thereafter is going to be when does the object stop, when is it going in a positive or negative direction, where is it at, that kind of stuff. So you either need to know a velocity or a position function to answer those types of questions. So again, this is typically the first question, and the directions to do that, just find the first derivative of the function. If it's already ready to go, fine. If not, maybe do some algebra to modify it so it's easier to differentiate. Question B. What is the velocity after 3 seconds? Okay, they want to know the velocity when it's 3 seconds. So the third second this experiment goes on, how fast is this object going? What's that?
T equals 3.
T equals 3 in the velocity function. So find the velocity at 3 seconds. So it's going to be 2 times 3 minus 4, which equals 2 feet per second. We are answering legitimate real-world questions here, so make sure you put legitimate units on your answers based on the units given to you in the problem. Velocity is going to be a unit of distance over unit of time. Distance in feet, time in seconds, so that's why it's feet per second. All right. Notice velocity is positive 2, so at 3 seconds it's moving in a positive direction. Okay, that might matter to us down the road here. Okay, when is the particle at rest? What does that rest mean? Not moving.
Yeah.
Velocity equals 0. Okay, so again we have a position and a velocity function, so we need to be very just accurate about what we're talking about. So at rest means not moving, so not moving means velocity equals 0. So to answer that question, when is the particle not moving, it's simply when does the velocity function 2t minus 4 equals 0. That's how we answer that question. When is something at rest? Yeah, when t equals 2 is going to be the answer. But again, in order to answer the question, when is the particle not moving, the velocity function should equal 0. The velocity should be 0. So, as Tyler said, the answer is t equals 2. That's seconds.
Is it just coincidence that the answer to B is 2?
That is a coincidence. It's 2 feet per second in B and 2 seconds in C. Okay. The numerical value is the same, but they represent different things. Okay. But they don't have to be the same number. Okay. They could have just as easily said, when is the velocity after 4 seconds in this question? This would have been 4 instead of 2, I think. Yeah, 4. Okay. They wouldn't have been the same at that point. All right. But again, notice putting units on there. The question is when. When is a time, so seconds. Velocity is a feet per second. Okay, so keep that in mind.
For part A, do you need a unit?
No. I mean, if you wanted to, it'd be feet per second. But as long as it's a function, it's fine to leave it in that without either. All right, moving on to question D. When is the particle moving in a positive direction? Okay, now, when we deal with problems like this, we're starting at a time of 0. So I'm curious, from 0 on up, when's it moving in a positive direction? So to do part D, it's real simple. I'm going to start at 0, comma, and then what I need to do is anytime it stops, it has the ability to change direction. I'll prove it. I'm moving this way, let's say this is a negative direction, and I want to start going that way. I have to stop first before I start going that way. That's just how it works. You can't start moving in a different direction without stopping first.
What if you go in a circle and come back around?
But we're moving straight line. Thank you for trying to find a loophole with that. That's good. All right. Anyway, so you're trying to move in a positive direction or a negative direction. Whatever direction you're moving in some direction. You can't switch direction until you stop first and then go the other way. So what we found in question C was when we stopped, right? So that means all the way from 0 up to 2, it's moving in some direction that it can't modify because it's not stopping between 0 and 2. And then at 2, it has the ability to go a different direction, but it doesn't have to. It doesn't stop anymore, so it's going to go all the way to infinity. So again, the particle could go for a little while, stop, and then keep going the same way. That's a possibility. So it doesn't have to change direction, but it's allowed to. Okay, so we have to answer this question C before we can worry about positive or negative direction. We have to know when it stops, so we know when direction change can happen. And this, we've done this before in other places, but we're trying to figure out these intervals signs. So I'm going to say time equals 1 and time equals 3. And what I'm curious about is direction that is moving, positive or negative direction. That has to do with velocity. So what I'm really curious about here is what is v of 1 equal to and what is v of 3 equal to. There's nothing magical about 1 and 3. I just picked a number between 0 and 2 and picked a number between 2 and infinity. I did pick 3 specifically because we already did that one. That's less work, right? So velocity at 3 is 2 feet per second, which is positive, right? It's okay that I can find the exact answer, 2 feet per second, but the sign's more important to me than anything. It's positive. V of 1, if I put 1 in here, I'm going to get 2 minus 4 is negative 2 feet per second. So I can see that at 1 second it's moving in a negative direction, and then at 2 it stopped, and then at 3 seconds it's moving in a positive direction. That tells me that as far as the question is, when is the particle moving in the positive direction? The answer is from 2 to infinity. And go ahead and use interval notation on these. It's just a nicer notation to use. T is greater than or equal to, or greater than 2 would be fine also if you wanted to. I just prefer interval notation personally. All right. And question E. Find the total distance traveled in the first 8 seconds. Now this is one that for some reason I don't understand why students have trouble with this, but they do. So I'm going to try and give you the same talk I give everybody else, and hopefully it makes sense. If there's something that's confusing about it, let me know. Okay? The ball's somewhere to start off with, or particle, whatever it is, somewhere to start off with. It moves in a negative direction for a little bit, ends up somewhere, and then it goes in a positive direction the rest of the time. Okay? So at 0 seconds it's somewhere, at 2 seconds it's further left of the somewhere, and at 8 seconds, because it says first 8 seconds, it's way over here somewhere. Right? So can we all imagine the particle moving? So it's here, it goes to there, and then goes back to there. All right? There's a difference between how far it traveled and its displacement from where it was to start off with. Let me give you the difference here. It started off here. It ended up here when it stopped. So this is 2 seconds. And then it ended up over here at 8 seconds. So this is 0 seconds. This is its starting point right here. Okay? It went that way, and then it came back this way. The displacement is this. Okay? That's what displacement is. How far are you from your original position? If I'm starting off right here, and I walk 2 steps this way, which is about 6 feet, then I walk 2 steps this way, which is about 6 feet, my displacement's 0. I'm in the same spot I was, right? But I went 12 feet. All right? So the distance traveled is 12 feet, my displacement's 0. The question they're asking in question E is, find the total distance traveled. How far did you go? They're looking for how far this is. This is some number. And then how far this is, that's some other number, and you add those two numbers up. Okay? That's a negative movement. This is a positive movement. So if we're talking about directional movement, we got a negative and a positive. I want all these to be positive, though. All right? So what I want to find out is, where am I here? Where am I here? How far did I go? From here to here, how far did I go? And it wants to know how far I went in each different leg of my journey. Add those numbers up. That's what I'm trying to do here. All right? So for part E, to do this and get the right answer, I want to do s of 0, s of 2, and s of 8. Sometimes it's more than 3 things I have to find in that step. It really depends on the problem. This problem here, what happened is we started at 0, stopped going left at 2 seconds, then started going right the rest of the way to 8 seconds, right? If I went from 0 to 2 seconds, and let's say I have some problem where I go to the right till 3 seconds, then I go back to the left till 5 seconds, go back to the right till 8 seconds, then I got more numbers in there, right? The numbers that are here are 0, always, 8 because it says 8 seconds, and 2 because that's where the particle stopped. If I stopped at 2, 3, 4, and 5, I'd want to do s of 0, s of 2, s of 3, s of 4, s of 5, and s of 8. It's 0 because 0 is always there, 8 because that's what it says, and then 2 because that's where it stopped.
Is that where other classes get confused?
I don't know, maybe. Again, I've had students, I'm not saying all the classes get confused, or all the students get confused, but the confusion is in this problem, this part of the problem. They get wrong answers on this, but I don't know why. I give them the same exact explanation I just gave you. We'll see if you guys make sense of it. I'll watch the video later if everybody gets it right all the time. I'll know this is the right way to talk about it. I might have made some different comments in it. I don't know. We'll see. S of 0, S of 2, S of 8. Again, how far did we go? How far is a function of distance, of position, where we're at? So S of numbers. S of 0 would be 0 minus 0 plus 2, which is 2 feet. S of 2 is going to be 4 minus 8 plus 2, which is negative 2 feet. And S of 8 is going to be 64 minus 32 plus 2, which is 34 feet. Okay. The position of this particle starts at positive 2 feet, gets to negative 2 feet, then goes all the way over to positive 34 feet by 8 seconds. That's what's happened, right? How far we went is just a matter of finding out how far part numbers are. How far is it from 2 to negative 2?
4.
4. How far is it from negative 2 to 34? 36. And if we add 4 and 36, we get a total of 40 feet. The displacement would be 32 feet. 32 feet. Started at 2, ended at 34, that's 32 feet displacement. But again, I traveled 4 feet this way, then 36 feet back the other way, so a total of 40 feet has been traveled. Alright? Question F, which, I think F might be more useful to put before E because it gives you a visual of what's happening too. I kind of walked you through it here. But if we look at F, it says draw a diagram like figure 2. This is in your book. I'll show you what it looks like and draw a diagram like what this looks like. But here's what we do. I mean, we need to have these numbers though, so maybe that's why E is first. Anyway, we'll see. So here's what happened. We started off at 2 feet, so t equals 0, s equals 2. Ended up at t equals 2, s equals negative 2. And then we ended up way over here at t equals 8, s equals 34. So I put a little number line kind of thing here. I want a time and a position of all the important places for us. I'm going to be drawing above this a little bit, so I'm going to shrink this down a bit. Okay. It doesn't have to be drawn to scale, but kind of get close. I mean, so those are kind of close together. This is way over here because it's a lot bigger. Where's the particle start?
T equals 0.
At t equals 0. This is the starting point, right? And what I want to do is I want to draw a diagram of the motion of this particle. Alright? And I'm going to use vertical movement so I don't want to go right over top of it or anything. But I'm imagining this particle just on a line, just moving back and forth like this. But we're going to kind of make it go like that. So just kind of do Tyler's circle idea. Alright? Anyway, but the particle goes back to negative 2 first, and then it turns around and goes to positive 34, right? So the motion of the particle starts here, and then it kind of goes like that. All right, it hits a point here, and we're going to put a point here just to demonstrate where it was at specific points. And then I'm going to put arrows on this line demonstrating the motion of this particle. Doesn't have to be beautiful arrows. All right. That's the motion of the particle. And again, that very well demonstrates that 40 feet. We went 4 feet left and then 36 feet right to go a total of 40 feet. All right, make sure that you give me distance, not displacement on question E.